Hello, everybody. It's nice to have this continued discussion. I appreciate the opportunity. And as I've mentioned in the previous discussions, my intention is to be helpful to you in your diplomatic journey. So today what I'd like to do is focus on the Arctic as a case study. So you will find, and I understand some students like it and some don't, but that's just my style. You will find that some of the slides are repeated. And the idea is to build on things that I've introduced previously. So if you see something that you've seen before, it's intentional. So the context of this entire discussion and all of the science diplomacy theory, methods, and skills are at this level. They're at the level of the Earth. They're at the level of the planet we live on. And they're with full recognition that we live in a globally interconnected civilization. And at that level, on a planetary scale, the challenge is to balance national interests and common interests. So recognizing that nations are the central jurisdictional unit, have been since the Treaty of Westphalia. On one side of nations are international, and on the other side of nations are subnational. And this is the world we live in today. So there are not just national interests, there are common interests that we collectively share. So we are concerned, for example, if we have a terrorist attack or a cyber attack, because it affects us all in one way or another. And so all of these things are relevant to the world we live in today, and we will give to our children and our grandchildren. So in this globally interconnected civilization, I've introduced the concept of a continuum of urgencies. Now, urgency is something that governments, particularly nations, respond to. So the aggregation of capacity in the world ultimately rests within national boundaries. We're each citizens of designated nations. So at one hand, the notion of urgency is what compels action by nations. And so understanding that at different time scales that are relevant to the welfare and security and sustainability of nations is important. So on one hand, we've got security timescales. And I mentioned, I shared this last week, but we have security timescales, risks of political, economic, cultural instability that governments will always find appropriate to address. So you can imagine if a government feels that their political security is being undermined, they'll do what they need to do. You know, sometimes it's repressive activities, but governments will respond in ways that they think are appropriate to political, economic, societal, and environmental instabilities, however they deem as appropriate. And at this level, it's a very much reactive timescale. And so there isn't great depth of understanding how to respond because often it's just reaction. On the other hand, we have urgencies, real urgencies that operate across generations. That's not something that we can start thinking about 50 years from now. Those urgencies begin at the moment today as well. And it's not a matter of prognosticating and saying that this will happen or this won't happen. The urgencies of the future start today. And in that sense, we have challenges of balancing environmental, economic, and societal issues, the prosperity, the protection, the well-being of our societies. And these collectively must be addressed by nations and peoples individually and collectively. It's our responsibility. And so part of science diplomacy training in this context is to alert you that you are an active participant in this process. It's not something that's relegated just to nations. You have an active role in this. And so the idea is that an informed decision operates across a continuum of urgencies, from security timescales to sustainability timescales on a planetary scale. And it's not one or the other, it's a continuum of urgencies. So you can imagine that the welfare of a nation is completely undermined if the thinking is only at this timescale, at the reactive political timescale. It's not the welfare of your children or your grandchildren that's involved. And so we have collective responsibility to think in terms of a process that operates across a continuum of urgencies. This process, this process leads to informed decisions. The process is a simple process. It's not complicated, and that's where the elegance of the process is important. Science diplomacy itself is a process. It's not a specific answer. It's not a magic bullet. It's something to be applied, to be trained, and refined. And it is with a significant level of responsibility in thinking about the world we live in terms of balancing national interests and common interests. In all cases, the discussions start with questions. Questions raised by individuals, by institutions, by groups in an undefined manner. But it starts with questions. Questions is also the least complicated stage to begin building dialogues and even common interests among allies and adversaries alike. So questions is a stage when there's no investment in terms of effort, no investment in terms of money, infrastructure. It's an uncomplicated stage, and it's a starting point, the least complicated starting point to begin building common interests among allies and adversaries alike. And when you talk about nations, it is a truth that each nation's individual interest, its own national interest, is different from every other nation's national interests. So all nations have different national interests. They may be aligned, they may be adversarial, but they're each different, defined by that nation. And so at this stage, when questions are being developed, it's also an opportunity to begin to build common interests, apropos of the discussion we were having earlier. When there are questions of common concern, it raises the challenge of identifying the methods to answer those questions. Now, the methods may come from the natural sciences, understanding how mercury is transported in waterways. It may come from the social sciences in terms of the number of deaths associated with mercury poisoning. It may come from indigenous knowledge in terms of these rivers were clean and there were legends of fishing in the past. But all of these different perspectives involve methods that can be used to create data to answer the questions. Important observation here is that data is different than evidence. Evidence is for decisions, data is to answer questions. And so there is a significant misuse of the term data and interpretation and calling it evidence. Data and evidence are different. Data is specifically an outcome, a designed and thoughtful outcome to answer questions. Evidence, on the other hand, is for decisions. And so if something's for a decision, it necessarily begs the question of who is making the decision. So at the stage of creating evidence, it involves the data and the questions for sure, but it also now adds an understanding of the institutions and the individuals that will be making decisions. When the evidence is essentially framed and presented to those individuals, it may or may not compel them to act because they're the decision makers. The evidence itself only is sufficient, however, to compel decision makers to act. It doesn't tell them exactly what to do. It just tells them to act. And that's the stage of options. Options takes the evidence, takes the data, and takes the questions, and frames it in ways that, best considered, have practical value in terms of solving problems that emerge from these questions. The options, however, is where the diplomacy comes into play. So As an individual without a power position, I don't have a authority given to me by anybody other than what I have in my head. How do I interact with decision makers? In some cases, these are presidents and foreign ministers and admirals in charge of navies and so on and so forth. How do I interact with those individuals in ways that is helpful? And the observation is that anything that I would introduce, I cannot be prescriptive. I have to respect that these decision makers are given that authority by institutions. So I have to respect that. So for me to make any assumption or recommendation to them to be intrusive into their decision-making process falls foul of what my role is in this discussion. My role is simply to contribute to informed decisions. So how do I do that? And the options is the stage of diplomacy. Really, it's the stage of diplomacy. These options, if you're the decision maker and I come up to you and I say, look, I've got a set of options, and these options can be used or ignored explicitly, I'm not telling you what to do. I'm simply putting something on the table for you to consider. You might say these options are useless and throw them away. You may decide that these options fit with other options and blend them. Or you might use this option, but the decision is yours. And so by saying to the decision maker that you can use or ignore these options explicitly, what I've removed is any advocacy. So I'm not advocating a specific solution. And the observation here is that whenever you have two agendas, you create a political dynamic. So between individuals, between nations, whenever you've got two agendas, you create a political dynamic. And advocacy underlies an agenda. And so the hard part in this discussion is that the assumption is that we have to advocate solutions to create change. And there are activities where you have thoughtful people presumably yelling at each other, advocating louder and louder to come up with specific solutions. I can only observe based on my own experience that being loud and being presumptuous in terms of having a specific answer doesn't work. And the challenge in all of this is a process. The process has to be continuous. And so if you stop the dialogue by saying something that doesn't engage a second or third or fourth discussion, you've effectively reduced the process to just a specific set of meetings. And so the idea is a process that's continuous. And the idea is to facilitate an ongoing dialogue where there's iteration from questions to data to evidence to options, ultimately to informed decisions. And arguably, an informed decision is the best we can possibly achieve at any time. It's not a right decision or a wrong decision. It's an informed decision. That means that we've taken all of the information and the questions and the data and the evidence and we've blended it together to reduce it into options, and ultimately with the idea that all of this well-being, well-thought, well-considered insight is transferred into informed decisions. And so the notion of an informed decision in terms of its theoretical proposition is it operates from global to local scales, agnostic of scale. So you as an individual, when you're driving down the road, I mentioned this analogy last week, are in a car, you have to be aware of the cars around you. So that's certainly the present. That's the immediate moment. At the same time, you have to be aware of the traffic ahead of you. And if you see the lights, that red lights in front, you begin to slow down or maneuver appropriately. And you have to be aware of the traffic behind you, if somebody's speeding up, for example. And so to operate safely in a car, you as an individual have to consider a continuum of urgencies, the things that are immediately around you as well as in front and behind. And it's the same at all scales, at the world itself, going from security timescales to sustainability timescales. And so it is in this context that what I'd like to do is introduce a specific example. I'd like to use the Arctic as a case study to illustrate the process of going from questions to data, to evidence, to options, to informed decisions. Now, one of the features in all of this to generate options in terms of mechanics is we need stakeholders. And the stakeholders that are involved have to be involved in an international context, in an interdisciplinary context, but most challenging and most difficult is it has to be inclusive. And so the concept of international, interdisciplinary, and inclusive is itself a puzzle piece. And that puzzle piece I define in terms of the word holistic. So when I use the word holistic, what I'm thinking about is international, interdisciplinary, and inclusive together at the same time. They're parts of the same puzzle piece. Part of it involves stakeholder perspectives, the evidence, the governing mechanisms to create the options. But you have to bring in the stakeholder perspectives. And ultimately, the reason for all of this is our sustainability. Our personal sustainability, the sustainability of our communities, the sustainability of our world, involving stability, balance, and resilience in terms of characteristics of what sustainability itself is, so that it is not jargon. And again, it's important to define terms. And so in all of these pieces, I'm trying to define terms that they can be reproduced with consistency in different contexts. It's the same term. When I talk about sustainability, I'm talking about stability, balance, and resilience. And it has characteristics such as sustainability classically in terms of environmental, economic, and societal, issues of urgencies, national interests, and common interests. But ultimately, the framework objective of all of this is to promote cooperation and prevent conflict. Without peace and stability, all of these considerations are out the window. Peace and stability, the ability to have these discussions in a classroom and to think about the future of our world only exists because we live in a peaceful and stable time. We're not in something of a global conflict. So here is the Arctic Ocean system, and I'm trying to be holistic. So my objective in this discussion is to be international, to be interdisciplinary and inclusive. And so the question I ask myself is whether I'm being all three of those things simultaneously. So if I were to define what the Arctic Ocean system is, on one hand it has the natural system characteristics, the nature or natural system. A system is defined by its boundaries, so this room is a system. It's got a floor, it's got walls, it's got ceiling, it's got inflow and outflow from the door. It's a system. It has boundaries, and we can characterize this room as a system. And it's a natural system. So in the Arctic, we've got the sea floor. You can see the bathymetry here, and Lomonosov Ridge. And we can see Canada and countries. We can see indigenous peoples. So the characteristics of this system, we can bound it by the Arctic Circle. So the Arctic Circle is at 66.5 degrees north because the Earth is tilted 23.5 degrees off of vertical. So 90 degrees minus 23.5 degrees is 66.5 degrees, which is why we have the polar circles at 66.5 degrees. That's how it's based on the tilt of the Earth. And that's the reason we have seasons, for example. So we can define the natural system. So that's part of being holistic. And the reason I have the I there, it's the three I's: international, interdisciplinary, and inclusive. On the other hand, we've got social features, not just the boundaries, the physical system. We've got characteristics of the Arctic Ocean in the middle. We've got Arctic coastal states. We've got Arctic non-coastal states. We've got non-Arctic states. And we've got global civil society. So at this level, clearly, I've included everybody on Earth right here. So it follows within my challenge personally of thinking in an inclusive way. Everybody is included right here for sure in this diagram. So what are the questions? What's an example question? So we'll just go through one example question and work our way through this process of informed decision making. So here is the sea ice that existed in the ocean in 2012. And the rest of this is open water, so everything that isn't white isn't covered with ice. And the yellow line here represents the average sea ice extent from 1979 to 2010. And so what we see right now is that most of the Arctic Ocean is open water. Historically, the Arctic Ocean had been covered by multi-year sea ice. So the sea ice could be many meters thick, tens of meters thick in some cases, floating on top of the ocean. It was a permanent ice cap, a sea ice cap. When I was in graduate school, which wasn't that long ago, I was in graduate school in the 1980s, the difference between the Arctic and the Antarctic was that the sea ice retreated annually in the Antarctic from 3 million square kilometers to 20 million square kilometers, in and out, oscillating year after year, whereas the Arctic was just solid multi-year sea ice. Miraculously, just an amazing coincidence, but during the era of satellites, from 1979 to the present, this change has occurred in the Arctic Ocean. More than 50% of the Arctic Ocean is now open water during the summer. So it's gone from a permanent multi-year sea ice system where the entire region was covered by sea ice 365 days a year for probably tens of millennia. Not just hundreds of years, but tens of millennia. And so now, more than 50% of the Arctic Ocean is open water. So if you remember the context of security, risks of political, economic, and cultural instability, the characteristic of a system, if you remove one of the boundaries of the system, it's no longer the same system. So imagine I remove the ceiling to this room. You're comfortably here with your jackets off, and suddenly you'd be exposed to the outside weather, the wind, the rain. Your movements in this room would fundamentally change. So whenever you change a boundary of a system, it's no longer the same system. It's a new system. And so what we have today is a new Arctic Ocean. As a consequence, these risks of political, economic, and cultural instability, they're not something that's going to happen 50 years in the future. When you've changed the boundary of a system, you've automatically introduced a new system, and everything associated with that system is new as well. So the risks of political, economic, and cultural instability in the Arctic are inherent. They're not possible. They're inherent. They're happening today. And it is a consequence of that that involves the entire world. It involves it in the physical sense in terms of the amount of reflected radiation that hits the ice and bounces back into space. It's part in terms of the shipping and commercial activities, fisheries, and so on that are part of the Arctic Ocean. But because it's a new system, there are inherent risks of political, economic, and cultural instability. It's not possible. They're inherent. They're already happening. And so when you see papers that refer to something of the Arctic Ocean being open water during the summer in 2050 or something like that, those are specious discussions. They have academic value, perhaps, in terms of models and so on, but they're not practical. The practical feature is the Arctic Ocean has already changed. It's a new Arctic Ocean, and as a consequence, there are inherent risks. And the challenge is to respond to those. So that's where the questions come in. And this picture right here is from the lowest sea ice extent that has been measured during the satellite era, so i.e. in the last several tens of thousands of years. And is also the cover to a book that I wrote with Alexander Vilijanin, who is the team teacher in the course with MGIMO. And that book was on the first formal dialogue between NATO and Russia regarding security in the Arctic Ocean. So again, that was a dialogue I convened not because I have the authority within NATO and not because I have any authority with any of the countries that were involved, but I acted as a science diplomat introducing a dialogue that was helpful. So that was the question. Now, the question is, we have this question and the relation of sea ice. All of these various stakeholders around the world are asking questions about sea ice. So in a sense, you have the opportunity at this stage to begin building common interests on a planetary scale related to the Arctic Ocean and sea ice. So it's a practical exercise in terms of how we're going to respond. How are we going to respond within individual nations, the United States, Canada, Norway, Russia? how are we going to respond as a group of interested non-Arctic nations, China, Japan, and so on, as well as the residents, including indigenous peoples that have lived there for tens of thousands of years. So all of these questions ultimately come down to use and change in the Arctic Ocean. Some of it's happening because it's changing in the natural system. So the natural system in terms of sea ice is an impact in itself, and understanding that is relevant. However, we also, as users of these systems, are impacting systems. Not necessarily always in bad ways, but we're impacting it just because we're there. And this is a picture of shipping in the Arctic. So if I want to understand use in the Arctic Ocean, arguably all of the use in the Arctic Ocean is going to be by ship, in the ocean itself. One form of ship or another, whether it's a surface ship, whether it's a submarine, whether it's an oil platform, all of those things are moved through the ocean by ships, or can be considered ships themselves. And so those floating things that are larger than a certain size, 200 tons, are required under international law to have what's called automatic identification system. It's basically a transponder that's on the ship, and it sends a signal up to either a receiver. The receivers historically have been on land, could be in a satellite. And these signals effectively tell the receiver where the ship is. And so you can track ships over the entire Arctic Ocean. So if I want to understand use, I want to create questions to understand the change of sea ice in relation to use, and one use is related to shipping, then the data that I have to collect relates to ships. And so this is the oldest continuous record of ship traffic in the Arctic Ocean. And I acquired this data set to answer these questions. So I understood that the questions relating to use ultimately had to be based on ships. And the satellites give us something that's very important. They're completely agnostic of any national jurisdictions. So I don't need permission from any of the Arctic states to analyze these data. It's out there for everybody to interpret. And I have acquired the longest satellite record as a process. So early satellites were launched in 2009. It goes up to the present. And the idea is to be able to use these data to answer questions. But the data itself is not evidence. And so this is the distinction I want to begin to introduce. So, oops. And if I go back for a second, you can see things in this data automatically. You can see seasonality, so ships are moving in and out of the Arctic. You can begin to look at subtle differences, like here's the Barents Sea, and ships are moving out of the Barents Sea during the winter and moving north into other parts during the summer, and so on. All of this is ship traffic in the Arctic Ocean. You can interpret it at all kinds of scales, from local to pan-Arctic. And you can create profiles. So I can take all that data. You can see the trends. You saw seasonality over time. Here, if I composite in terms of spatial extent, this is what it looks like in terms of the entire number of ship visits between 2009 and 2016. And so this is a composite. We can clearly see that there's a great deal of use in the Barents Sea. And part of that is because the Barents Sea is open water all year round. And so I didn't make any subjective decisions about analyzing these data. I analyzed everything north of the Arctic Circle. So I didn't make assumptions about which territory it was. I didn't make assumptions about what the sea ice looked like. I just made a decision based on a non-arbitrary, completely objective physical parameter of the system, the boundary of the system itself. I define the system as north of the Arctic Circle. The Arctic Circle is a physical boundary on Earth. It's related to the tilt of the Earth's axis and the amount of sunlight that comes down on the Earth. So in creating the system, I define the system north of the Arctic Circle, and with that I can begin to create understanding of what the impact of shipping in this area is. And we can see, for example, there's a great deal more shipping in the Barents Sea over time. Now, you might ask, what's this going to look like into the future? Here's the Bering Strait, and between the United States here and Russia here. So it's an interesting feature. The United States and Russia are these historical adversaries, yet their countries are only 2 miles apart between the United States and Russia. And the United States and Russia share the longest maritime boundary on Earth that starts in the Chukchi Sea, goes across the Bering Strait into the Bering Sea. It's over 1,000 miles long. So the United States and Russia are significant in this, and any discussions about this are clearly incomplete without engaging Russia. So these are data. We're still at the data layer. And again, the questions that I was asking related to sea ice. So here's the satellite record of sea ice. It's retreating over time, and you can see the change. And then we have a similar record of shipping over time, and you can see the shipping increasing over time. And you can begin to see things like, which is in a practical sense, the difference between these two bars, heights. These are ships that are registered with the International Maritime Organization. So there's a decision-making body. So these are registered ships with the International Maritime Organization. They have characteristics like the size of the ship, the registry of the ship, the name of the ship, and so on. These other ships are not registered with the International Maritime Organization. And so if the objective, for example, just thinking out loud, if the objective is safety at life at sea or to reduce impacts of pollution, these ships that are not registered with the IMO, the International Maritime Organization, are actually greater at risk because they're not constructed under international norms. And so these are the ones that are actually more risk, and they're growing faster in terms of number over time than the ships that are registered with the IMO. So we have a challenge, and this is, for example, an option just based on an initial observation that I will suggest to the IMO in terms of consideration of how they manage shipping in the Arctic. That's an option. So I've now considered the decision-making institution. I've blended these data into evidence that there's a difference between two types of transponders. One is not measured effectively by the IMO. The objective ultimately, however, based on our question, was to understand the relationship between sea ice and shipping. And you can see sea ice is decreasing as shipping is increasing. And so you might assume that if you're looking at shipping, that it's going to grow as fast as sea ice is increasing. That doesn't necessarily include any understanding of what's coming out of beyond the Arctic. Is shipping growing globally, independent of the Arctic? If so, then that global influence is clearly going to have a role on shipping in the Arctic. And so one way of answering that question is to look at the Barents Sea, which is open water, and to interpret whether shipping is increasing in the Barents Sea in open water over time. And that would be an indication that shipping is increasing because of global things, not just because of the sea ice, for example. And with these data, we can go down to individual ships. We can look at the movements of individual ships, and we can see their tracks. Presumably, we can go backward in time and look at ships that have been in distress. So if a ship suddenly sinks, we might assume that there's some pattern that relates to that ship's activity that we could use to respond to an emergency. So for example, a plane is going from New York to California. The plane goes across the United States. Every state it goes across picks it up on the radar, transfers it to some air traffic control, hands it off to the next air traffic control. The plane is expected to travel at 35,000 feet. If it suddenly goes down to 15,000 feet, all of these lights light up across boards because something has happened that isn't normal. Same way with shipping. It is possible to detect abnormal activity and perhaps use that as a way of interpreting how to respond. We can see, in this case, all of the red areas here are Russian icebreakers and ships. And so the question that we were looking at was relation of ships to sea ice, and we actually measured the number of ship-ice interactions in each 4 kilometer by 4 kilometer grid spacing across the entire Arctic Ocean from 2009 to 2016. So it's a big data exercise that involved terabytes of information. And with the tools that we're using allow us to process this in a matter of seconds. So we use Google environment to BigQuery to upload the information and analyze it at scale within a matter of seconds. And ultimately, we can reduce it to ship interactions by latitude and year. And so here what we see is 2009 to 2016, and the red is more ships, and we can see that the number of ship-ice interactions is increasing at higher latitude over time. So these are things that give insights to decision makers, different types of decision makers. If you're considering operational decisions in the Arctic, how do you respond to them, and so on. But the data themselves are to answer questions. So these are formulated because I asked a question about ship-ice interactions across latitude and time. The result of this, however, gives me insights about its value, perhaps, in terms of a decision-making environment. And that's where the evidence is created. It's not just because I feel that ships are increasing at higher latitudes that I suddenly have to respond to ships. That's an incomplete answer in terms of creating the evidence. Part of the process of creating evidence is understanding the institutional boundaries. So we have boundaries in the system. Here are boundaries of large marine ecosystems, for example. We characterize this based on different types of species and different types of water masses and currents and so on. And we have large marine ecosystems that are described, in this case by the Arctic Marine Shipping Assessment. We might characterize the distribution of people or the Arctic based on temperature boundaries. So this is a uniform temperature boundary across the Arctic. And then we might characterize the systems, the boundaries, based on actual institutions. So this is the Arctic Search and Rescue Agreement, and it has broken or divided the Arctic, separated national interests and authorities and capacities into areas. And those areas effectively are areas of competence in terms of being able to hand off responsibility as activities occur in those areas. But you can see we're talking about an ocean. And the ocean is dynamic. And so what happens to one area in the Arctic happens to all other areas in the Arctic. And this is the case of the Polar Code. The Polar Code was designed based on where the sea ice was when they began talking about a polar code. They drew this line. And the sea ice is continuing to move into the Arctic, and so at some point this is going to be recognized as completely artificial boundary when they created this. So the challenge is we still have to respond to the jurisdictional dimensions of the institution. In the case of the Polar Code, it's this specific boundary, even if the sea ice has no resemblance to this boundary in the future. So evidence, in sense, is understanding the institutional boundaries. And that gives you a starting point to define who you begin to work with. Does the institution that you're talking to specifically, because you have insights from your data, does it relate to a specific boundary that your data fits into? So the institutional dimensions are critical to framing the evidence. The evidence about ship traffic and so on only relates to those authorities that have any oversight for those activities. It's not something that can be cast on the water out in a newspaper because you don't like it. It has to be brought together in a very manageable manner. The information, the data is represented in the context of an institution and its authority. It then becomes evidence. And so the evidence is created in the context of boundaries. And the boundaries relate to the institutions, and if you do your homework properly, then what you find are the individuals in those institutions that are responsible for those different boundaries. And then if you want to go further and to facilitate dialogues, you know who to bring into the dialogue. Who are the point of contacts that have the specific authority for those specific institutions? And imagine putting them together into a format where you as an individual don't have any skin in the game. You're not a decision maker. So you're in a position to balance adversaries and allies alike in a dialogue, which is exactly what I'm doing this Friday, which is what I did with the NATO Advanced Research Workshop and so on. I understood who the individuals were in these different jurisdictions, and I invited them to a discussion. I invited them without any political dynamic involved. The evidence also goes into the institutions itself. So it's not just a matter of saying, well, this institution has specific authority. You have to understand something about how about the institution, how it operates. So a good example is the United Nations Convention on the Law of the Sea. It's a complicated, extensive agreement, and it involves all of the nations in different ways, some with more or less buy-in than others. The United States, for example, signed the UN Convention on the Law of the Sea, but didn't ratify it, meaning that it didn't bring it into its mechanism of the Senate and bring it into the Foreign Affairs and have it approved as into force for the United States. So there's a difference between acceding to a convention or a treaty and ratifying it. And so in the case of the United Nations Convention, it was signed in Jamaica in 1982 and it entered into force in 1994. That means that in the convention itself, there were certain types of requirements as to how many nations had to ratify it individually for this convention to come into force. So it entered into force in 1994 after those requirements were met. And now it has more than 160 nations that are involved in the United Nations Convention on the Law of the Sea. If you look at it, it is, for all of the issues that are associated with land, there are issues associated with the sea. And in the same sense, we've got the nation state, which are land areas. So all the land areas, with the exception of Antarctica, fall within national boundaries. And in the case beyond the national boundaries are international spaces. And the United Nations Convention on the Law of the Sea was very explicit about this. They identified national airspace and they identified internal waters and territorial sea and a contiguous zone out to the edge of an exclusive economic zone in the water column, 200 miles off the coast. They also identify the characteristics of a continental shelf. So the continent, the land area, is different than the shelf or the crust of the earth and the ocean. So you got continental crust, which is relatively light, and so it floats, and oceanic crust, which is relatively dense, which is why it's at the bottom of the ocean. So we have continents on top because the crust is much lighter than the crust in the ocean. That's the reason we've got continents and ocean. And the continental shelf goes off and they define it in terms of a shelf edge and slope and break and so on, and they define the characteristics of where a nation's jurisdiction ends on a continental shelf. In the water column, beyond the exclusive economic zone is an area called the high seas. High seas, by definition, is an international space. It is beyond sovereign jurisdictions. It was signed, the Convention on the High Seas was signed in 1958. The United States is a party to the UN Convention on the High Seas of 1958, which means that under U.S. law, the high seas is defined explicitly as being beyond 200 miles off the coastal boundary. The contentious part for the United States has to do with the deep sea. The deep sea is beyond the continental shelf, but it also, under the UN Convention, allocates rights to exploit in an equitable manner resources in the deep sea. And this is a challenge in terms of both biodiversity and minerals on the seafloor beyond national jurisdictions. And so this is the environment. Just like on a planetary scale, it involves nation states on one end and international spaces on the other, and really, again, goes from national interest to common interests. So if we're talking about the Arctic Ocean, at one scale, at the most macro scale, it falls within the context of the UN Convention on the Law of the Sea. The UN Convention on the Law of the Sea is the umbrella for all things in the ocean. Now there are vast mechanisms, and that is the reason for the International Maritime Organization itself, to be able to manage all of these different connections that happen at different scales in the context of the ocean on Earth. But this is the overriding jurisdictional environment. So if you're building evidence at one scale, it sits within the context of the United Nations Convention on the Law of the Sea. So we've now created the questions, we've gone through the data, we've even blended some evidence. And now we create options. So these are real options. These are things that I'm actively introducing. These are for decision makers to use or ignore explicitly. So it's an ongoing iteration of questions to data to evidence. It's not just a specific answer. It's not just one solution. And so there was a previous type of shipping assessment in the Arctic. The sampling period was 1 year, and it was based on ground stations, each of the Arctic states individually. The observation period coverage was regional. The observation scope was ground-based. The observation frequency was inconsistent over time and space. The ship type designations were variable and by nations. Individual ship metadata in terms of characterizing the ship wasn't available. Contributions were recommendations and scenarios. So that's what this shipping assessment produced, was recommendations and scenarios. And the decision support was specifically related to governance mechanisms. So in contrast, with satellites, we now have continuous data, sampling period from 2009 to the present. It involves diverse governments and commercial automatic identification sources. Point, regional, and pan-Arctic, ground-based and satellite, synoptic and continuous. Synoptic meaning it's all measured simultaneously in all these different places. Standardized designations of ships. There was a maritime mobile service identity of each ship involved. Options based on spatial and temporal evidence, so at diverse time and space scales. And the decision support relates not only to governance mechanisms, but also to the built infrastructure and to operations. So this is an option. This is an option for all of the governments, United States included, to use the satellite data in a way that ultimately contributes to the built infrastructure decisions, decisions about operations, and decisions about governance mechanisms. So those satellite data on the ships ultimately is very central to all of these types of decisions. And the challenge that the governments face, the decision makers, is how to use this data in a way that's efficient and effective in terms of making informed decisions. So it does not rest just with the decision makers to figure this out. That's where our responsibility is collectively. We each can think of things and introduce them, and I'm trying to share methodology for you to take your insights and to put them into a form that they're helpful to decision making. So these are where the options come in. An option also might be in terms of the governance mechanisms. At one level, clearly we've got stewardship from the Arctic states. So the Arctic states have their national jurisdictions, and they are stewards in terms of the Arctic. At the same time, we have engagement with non-Arctic states and with global civil society, that bullseye diagram. So it's not just the Arctic states and residents. We also have engagement with non-Arctic and global civil society. On one spectrum, we've got applications of sovereign jurisdiction. And on the other, we've got applications of international law. And so if you imagine how all of this fits together, all of these different types of interests, one observation is that if we have economic prosperity, societal well-being, and environmental protection, the capacity to pursue all of them ultimately relates to economics. And so when we see discussions in the media, at some point they relate to economics. And it was interesting, I was at the House of George Washington, Mount Vernon, in September. And President Washington, George Washington, General Washington, was a very successful landowner. He had crops, he had employees, he had a very successful farm. And he was an entrepreneur at the time. And in the same sense, the reality is that any of these decision-making activities ultimately have to be framed with capacity, and it comes from the economics. And so the economics, arguably, there's an economic engine in this discussion. Somehow we have to figure out how the economic engine fits into an environment where there's stewardship from Arctic states and interest from non-Arctic states and international law and sovereign jurisdictions. Somehow we have to figure it out. And the argument here is that the center of the Arctic is this economic engine, and it's sort of like a boiler. You put a boiler in your basement and you don't anchor it properly to the floor, it's going to bounce off its foundation and explode. And in the same sense, this economic engine in the Arctic has to be anchored properly. It has to be buttressed in ways that it doesn't bounce off its foundation and explode. In this, we can get into further detail in terms of how these economic engines can operate. Well, we've got two different bases of financing. One is equity, and so we have relatively short-term investment where people are coming in, they're taking a piece of companies and they're interested in a relatively quick return on investment and an exit. And then we have debt, and the larger amount of financing in the world is debt, sovereign wealth funds, institutions. And these debt repayments effectively are long-term interest payments on the debt. And so we have 6 or 8% return on the investment debt over a century. Those countries, those investors are doing great. And this is exactly the discussion that's in play with the Belt and Road Initiative from China. China is looking at long-term debt in terms of being able to acquire a stable return on its investment over a century. So this is exactly what China is imagining, is this debt investment into these infrastructure. But the observation is that you can only have a sustainable solution if the governance mechanisms and the built infrastructure are coupled. So if I have a group of governance mechanisms, so in the Arctic specifically, we've got a search and rescue agreement. It's a perfectly forward-looking agreement. We have a pollution preparedness and response agreement, perfectly forward-looking agreement. But there isn't the built infrastructure, the ports and the ships to implement them. In the absence of that built infrastructure, those agreements are hollow. And so the challenge is to couple the built infrastructure with the governance mechanisms. Similarly, if you had a bunch of ships that were operating around the Arctic and they weren't coordinated and there wasn't cooperation and consistency in terms of their governance, you wouldn't have a sustainable solution either. So it's a coupling between the governance mechanisms and the built infrastructure. So this is in Bloomberg in 2016. The world has discovered $1 trillion ocean. So this came out of the World Economic Forum in Davos, and they were talking about this new Arctic Ocean, the one we've just discovered, this new Arctic Ocean, potentially has $1 trillion of investment going into it. Now, I've heard numbers on the order of $12 trillion of unspent capital in the world, so that's something on the order of 8.5% of the outstanding capital would be invested in the Arctic on a planetary scale. That's a large number. And then we had strategies that come out of this in terms of Arctic investment and guidelines and so on. And we can imagine that over time we're going to begin to develop infrastructure around the Arctic as shipping and activities begin to increase, as the sea ice begins to continues to decrease. Shipping is going to come in. We're going to have to build ports. We're going to have to build emergency response systems and communication systems and information systems, things that all require technology and capitalization. So in terms of options, one option Right now, all of the governments that are talking about this are thinking in terms of investment and making decisions in the Arctic. Their time frame is now. And I would argue that the investment strategy across the 21st century is just an arbitrary point in time, but across generations will involve several phases. The phases all begin at the same time, but it will involve phases. And arguably there's an anchor phase, a phase that begins when the governments themselves collectively agree to begin to put the investment in to establish some level of pan-Arctic infrastructure. So they've already started this process by facilitating the agreements. The next step beyond the agreements is to actually act on them and to build the infrastructure. So some level there's going to be an anchor phase where they're going to have levels of international cooperation, coordination, and consistency in how to approach the development of this built infrastructure on a pan-Arctic scale. Somewhere along the way, the nations themselves utilizing this infrastructure will go through national and subnational services. So the nations and regions in the Arctic will begin to sell services. They have to do things like resupply ships or tugboats or whatever they have to do to move cargoes in and out of areas, to move, make sure that the ships are operating properly, that they have the necessary facilities. So there'll be services that are sold. And ultimately, across this entire spectrum are going to be things that are market-driven activities, fisheries, the ores that are brought in and out of the Arctic, and so on. And ultimately, as a concept, that there are just phases of investment in the Arctic is itself an option. So in terms of the people that have the resources, the trillions of dollars to spend, at some point, they're thinking at scales beyond the moment. They're thinking on the order of decades. Certainly something like an energy company, when it makes its trillions of dollars of investment, they're thinking decades, 3 to 5 decades in the future. The same thing is relevant to how we operate in the Arctic. And so the notion of options for built infrastructure, investment, these are active discussions. Ultimately, what we get down to are very practical things. All of these options and all of these for built infrastructure and governance mechanism ultimately have greatest value if they balance national interests and common interests. If they promote cooperation and prevent conflict, then all of these options ultimately have a real value. And one of the things that has emerged in the Arctic, which is important, is that we have a high north that's a region of low tension. So the United States and Russia in specific are adversaries yet again. However, in the Arctic, they're cooperating. The Arctic Science Agreement, the Search and Rescue Agreement, the Pollution Preparedness and Response Agreement, all involve the United States and Russia as chairs of the task forces that built those agreements. So something's going on in the Arctic that has enabled the Arctic to be insulated from global geopolitics. And so those questions are the essence of science diplomacy. Understanding how a region like the Arctic can be insulated from global geopolitics reveals the mechanisms. And the mechanisms ultimately have to do with science. Science builds common interests. I would say it, among all of its contributions, it builds common interests, has the capacity to build common interests. And in the Arctic, that capacity has matured through an Arctic Council into individual agreements that are signed by nations together. But ultimately, it comes down to a matter of balancing national interests and common interests. And the reality is that nations will always first and foremost look after their national interests. As long as there are nations, that's a reality of the world we live in. On the other hand, we've got common interests. And so one way of contrasting the Arctic, like the rest of the ocean, is in terms of the seafloor versus the overlying water. So I showed you the law of the sea convention. Law of the Sea Convention basically has two different levels or layers in it. One is the water, and one is the underlying seafloor. And so if we look at the two in the Arctic Ocean, we've got the nation states thinking about their extended outer continental shelves in the context of the seafloor, potentially all the way to the North Pole. And so if we use, for argument's sake, that the Arctic Ocean all the way to the North Pole, just for discussion purposes, belongs to one of these or more of these Arctic states. And the entire seafloor is part of a nation, so that it follows all in national jurisdictions. The overlying water column has in the center of it an area called the high seas. And the high seas is unambiguously beyond sovereign jurisdictions. It's beyond the exclusive economic zone. So this is an unambiguous international space in the center of the Arctic Ocean. And there are now things like a new fisheries agreement dealing with protection of fishing stocks in the center of the Arctic Ocean, involving 5 of the Arctic states and 5 other actors. 6 of the Arctic states and 4 other actors, including Iceland as one of the Arctic states. And these involve common interests. And so in a sense, we've got this juxtaposition of national interests on the seafloor and common interests in the overlying water column. And so again, to be inclusive, it has to involve everybody. Everybody. That's the challenge. And so one way of thinking about everybody, if we look at the nations, they've got their national interests. They're effectively the bounding continental areas looking inward into the Arctic Ocean. The international space in the center of the Arctic Ocean, in terms of common interests, effectively involves all of humankind looking outward from the center. So we've got this dichotomy between looking inward and looking outward. And it is this balance that is going to influence the stability of the Arctic going forward. So these are options. These are all options that are being introduced into various discussions. And ultimately, through this process of going from questions to data to evidence to options, we get to informed decisions. And here we have informed decisions in the Pan-Arctic context. That end is a speech that was given by Mikhail Gorbachev in 1987 in Murmansk, where he talked about the North Pole as a pole of peace. And he set in motion the context of the Arctic Council. He set up the idea of an Arctic Research Council. And eventually in 1996, the Arctic Council was established. And then in 2007-2008, Arturo Chologarov planted a flag at the bottom of the North Pole using the submarine Mir and basically changed the dynamic of Arctic states. 2006, Norway had identified a national security policy for the Arctic, and following the flag planting, all of the Arctic states established national security policies for the Arctic, and a number of non-Arctic states subsequently have created national security policies for the Arctic. And so, in a sense, the notion of informed decision-making is represented individually and collectively by all of these different agreements. They are iterative. And the idea that there's somehow a singular magic bullet that's going to answer the Arctic across the future is not realistic. The process is one of iteration. It involves questions to data to evidence to options, ultimately to inform decisions. But it is iterative. And all of these different agreements and policies and strategies affect this iterative process. So, just as a way of closing before we go into discussion, there is an article that is about the Arctic. This was written in Science in November of last year. It relates to the science agreement that was signed in 2017 that came into force in 2018, May of this year. And it recognized that an Arctic Science Agreement, an agreement on enhancing international Arctic scientific cooperation, was explicitly involved with the scientific community. So you could have an agreement that was developed by ministries of foreign affairs, but in order to implement it, it must involve the scientific community. And so the idea was that to bring together a group of scientists in Russia and the United States across different science organizations and to think about how to effectively implement this Arctic Science Agreement. And it basically involves some level of dialogue, ongoing, continuous dialogue between the diplomatic community and the scientific community. And so again, just taking these lessons of science diplomacy and introducing things without advocacy and bringing together dialogues. This article was introduced at a meeting in Moscow in November of 2017 at the Russian Academy of Sciences, and it began a process of dialogue between decision makers and the scientific community. The most recent iteration of this will be on Friday at a meeting in Reykjavik, where the discussion will involve 4 ministries of foreign affairs along with the three of the science organizations involved in the Arctic, as well as an upcoming Arctic Science Ministerial that will happen next week. So this is a specific example, and all of what I've shared with you in one way or another is reflected here. And so what I'd like to do is to open it up to discussion. I mean, this is intended to be a dialogue, and today's discussion was a bit more lecture-oriented than last week, in part because there's a level of passion that I'm trying to share with you and experience specifically with regard to the Arctic. But I'd like to go into the next stage, which is your specific research. And I handed out last week a table. You've got a copy there on the other side of it. Yeah. And the idea is for you to think in terms of your own research. So each of you in one way or another is completing a capstone. And the capstone has a specific research focus. It some way relates to natural systems or social systems or both. They've got some geographic dimension to it. They've got some time frame associated with it. And the objective here is for you to enhance your research, your specific research, by understanding how to apply science diplomacy. So it's not a matter of changing your research direction, it's a matter of enhancing the research. And so this applies to all of the natural and social sciences. In the same sense that I was introducing to you the natural sciences, social sciences, they all deal with change. They all deal with patterns and trends, and the patterns and trends become the bases for decisions. And so even though there are different methodologies in the natural social sciences, they ultimately influence decisions. And it is that capacity to be able to contribute to informed decision making that I'm trying to enhance in the purpose of this dialogue. So, is anybody like to share what they're doing for their capstone as a test bed for the discussion?
I have no idea yet.
Okay. Any ideas? No ideas. So, yes?
Yeah, sure. I'm I guess looking at the interplay between Soviet and Chinese influence in the Burmese public sphere and the Burmese press in the 50s and 60s.
Okay. So when you look at this context of the 50s and 60s, are you interested in some use of that information? Is it intended to be more than just a historical context?
Yeah, I mean, I think it informs, it's obviously greater than a historical context. It informs a lot of how different countries relate today, how public opinion is formed today.
Okay. So the starting point for this discussion is a matter of personal preference. So recognizing that science, natural and social sciences, indigenous knowledge, on one end can be completely basic, have completely academic purpose, it has no application at all. just because the love of studying something, stamps or whatever. That's perfectly fine. But if you have, and it's a big if, but if you have a sense of responsibility and you would want to contribute to a decision-making system, then the context of how to take your insights and put them into that system in a way that's helpful is important. And so it's a choice. If the answer is yes, you'd like to contribute to decision-making, then going through these types of categories, so the time that you're looking at, you've got change in time of space, the 50s and 60s. Now something in terms of the 50s and 60s happened that allows you to characterize patterns or trends. So there was something that you learned that happened during that period that some way is relevant to the future. But your data points are only related to the questions of the 50s and 60s. So you have to understand at one level how that period relates to decisions that might be made today. So something out of that gives you those insights. To reveal that, is what happened in the 60s related to monitoring the change, the Earth system itself, rivers and floods, or anything like that?
Yeah, I mean,
Forests or...
Look at the Sino-Soviet split, and that has a very real impact for change in his social relationships to a lot of the natural resources.
Okay, so maybe this isn't relevant really. That's okay. Science is an early warning system. Was there anything that was happening at the time that was set up specifically to be the canary in the coal mine? Something that was happening, were there measures in place? Maybe, I don't know. Were there?
Maybe within the press, or you could say, a gust for press freedom, maybe.
Okay, so that's a good point. You know, perhaps the press freedom here was an early warning system itself, that the repression of free press or something like that was an early warning. So, you know, there might be indicators that you could use, again, in the purposes of an early warning system. Was this early warning system of an international dimension? Was it press that was restricted within the country or around the world? Was it from one perspective or another? Did it occur just because of groups of individuals, or was this across the society? Was it inclusive in terms of the discussion about that early warning system? So you can begin to add additional conceptual framework to allow you the capacity to introduce options and evidence into decision-making systems. Was what happened in the 1950s and 60s translated in some way into public policy agendas? Well, what were the changes that occurred in the 50s to 60s as a consequence of those events that you're profiling? Again, you've got more information. Those public policy agendas, were they just within Burma or that area? Were they related to the US and China more broadly? Were there broader agreements? Was it international? Was it interdisciplinary? Was it focusing only on land areas, or did it address economic, society, and environment together? Again, brought into international legal institutions. Did this change the investment in Burma? Was there a level of commercialization that happened as a consequence of something, or that was stimulated by these events in the 50s and the 60s? Again, international, did it involve investments outside of Burma? Is it relatively closed still? Science is a tool of diplomacy to build common interests. Well, question here is, are there common interests? If not, perhaps we can identify why those common interests don't exist. And ultimately, thinking in terms of the adversaries and the allies alike. So it's not just a matter of building common interests. It has to be a process that engages all of these different stakeholders. So I would ask, as an exercise, since this dialogue series was designed to be helpful, And the objective is for you to learn with each other. And as I introduced the very first dialogue, I would like to be helpful in ways that are general of use to the Fletcher School, to your colleagues and yourselves. And so I imagine, just thinking out of the box and trying to be helpful, that if you each go through this exercise and ask questions yourself, ask questions, imagining the stakeholders that are involved, and ask questions and go through the questions into the data. The data is your research. And you think of that data and those questions in terms of evidence for specific types of decisions and who the decision-making institutions are. So in the case of Burma, who would the decision-making institutions be? Government of Burma, presumably subsets of the government of Burma, perhaps China, United States, other. So for example, so understanding who those institutions are allows you to characterize your evidence and options in a targeted manner. And ultimately, the idea is that if you share this with each other, you can begin dialogues. It's not so much dialogues that are specific to Burma, which presumably there aren't many people at the Fletcher School studying, but the context, these generalized contexts for asking about the relevance of that in terms of decision making, you may get positive feedback from your colleagues. And the idea is to enrich and enhance the research that you're each doing by making it accessible and functional in ways that will ultimately contribute to decision making. So the Fletcher School has as an objective to train in law and diplomacy, which means that you all are diplomats going out of here in one way or another. It's not that you're given authority by any individual. It's how you act and respond. And so part of this is tools and methods. Anybody else want to share what they're doing for their research, their capstone? How about your research?
It's not really well defined yet.
Okay.
So it's about fire management in Alaskan forests.
Okay.
And indigenous communities manage a lot of the lands there.
Okay.
And they just entered the Californian cap and trade system.
Okay.
So they're selling their like carbon rights.
Mm-hmm.
And the broader fire management community is now worried what that will mean for the total management system, if it will change the way they will manage the fire. Yeah.
So effectively, when these fires are happening, they're burning up their assets as part of cap and trade.
Yes.
So there's an economic incentive that's different than normal in just preventing fires or so on. So part of it, in terms of the Earth system, relates to the frequency at which those, sure, have a good afternoon. Thanks, you too. Relates to the frequency at which those fires are occurring, whether they're occurring more frequently, what are the conditions. Are there early warning systems that are involved? It's things that you imagine if you wanted to respond to the fires, are there things that you can do that are going to be diagnostic, that are going to help you reduce loss by fires? Are those solutions just within Alaska? Are they international solutions? Is it beneficial for other nations to figure out those same solutions because they could be at risk in Canada or in Russia, for example, for the same reasons, if there's, let's say, certain things that are happening? So what are the dimensions of early warning systems? Think in terms of solving a problem. You've identified an interesting problem. You put it out as cap and trade, you're burning up assets, you're presumably damaging communities, and when the fires burn, also they contribute to carbon dioxide in the atmosphere. So it's all well and good to figure out how to reduce fires or manage fires effectively. And perhaps there are early warning systems, and perhaps there are policy agendas that could be established. Is the fire occur more frequently in areas that are around cities or away from cities? What are the dimensions of the policies that can be created? So the geographic dimensions of this. International legal systems. Are there systems that are in place to address this? So the idea is to go through this exercise and ask yourself lots of these types of questions and to begin to fill in boxes in ways that are not designed to change your research in any way, but they're designed to enhance them. And ultimately, the product of this exercise, this holistic integration, this international, interdisciplinary, and inclusive integration, the product of this is to contribute to informed decision making. So you've made a decision, for example, to participate, not just basic research, there's an application. So where there's an application, holistic integration is a skill. The ability to integrate international, interdisciplinary, and inclusive is a skill. And the way to break down that skill into bite-sized pieces is to consider the types of questions where international, interdisciplinary, and inclusive apply. So this is a skill. And my objective here is to help you train and build this skill so that you become effective as contributing to informed decisions. I note we're at the 2 o'clock witching hour. Are there any questions that you might have? Are these discussions helpful? I mean, I'm trying to, again, the objective is to be helpful. Are they helpful?
I mean, for me, it's an introduction to the area. I didn't know anything about it, so I'm just starting to
Okay.
pick up tools for the toolbox.
Tools for the toolbox. Excellent. I'm going to be away for the next week. I'll be back Thursday and Friday next week if there are any questions. And then I understand there's a dialogue next in November. Is that the last dialogue?
That's right. So we've had our first 3 dialogue sessions, and the last one, I believe, will be November 17th.
I think that's correct. So I will be mostly on travel between now and then. So I'll ask Iceland this week, and then I go to Helsinki and Tokyo, and I'll be back on the 13th of November. But if you send me messages or questions, I will do my best to answer them. It's one of the features of the internet.
It's the 14th. not
14th?
the 17th.
Okay,
Yes.
that's good. Great. If there are any questions, I'm happy to answer them. How's your classes going? Difficult? A lot of classes? A lot of work? Always? Well, if it's any consolation, it doesn't decrease. And I would say probably more to the fact it only increases. If you're doing well, it only increases. And so the skills that you have to imagine is that everything that you do today, however long it takes you to produce a paper or anything like that, in the future it should take you an order of magnitude less time. So what takes you a week to produce should take you a day to produce. What takes you a month to produce should take you a week to produce. A year to produce should take you a month to produce, and so on. Those are the skills that you need to develop, because at the end of the day it's a matter of juggling. And the people that are most successful at this, the ones that are most capable, are the ones that give you the answers immediately. They're the ones that give you responses with red ink all over the papers, and they've read it. And these are the people that are running meetings and coordinating things around the world and discussing and so on and so forth. So it is important in your travels to think in terms of enhancing your efficiency in ways that make you more capable, constantly pushing to become more efficient and to be able to take on more and more and to do it with the greatest of ease. So I'd be happy to answer any questions if you have any. Respond over internet, but it's a pleasure and an honor to share ideas with you. We're on this journey together. There is a level of responsibility to solve things that have a global impact at local levels as well. Okay, well, thank you very much. It's a pleasure, and look forward to seeing you in a few weeks.